Hi, my name is Neha, and this is Physics Lab Report number 1 on constant velocity. So I will be talking about the fundamental physics principles, which is the introduction, the overall experiment and assumptions, the tracker analysis on the rolling string, the computational model using GlowScript, the graph and the overall results, along with the what ifs and what does it mean, which would be the overall conclusion. So an introduction to the key concepts used in this lab are Newton's first law of motion, constant velocity, and the different formulas. So Newton's first law of motion is that an object at rest remains at rest, and an object in motion remains in motion at constant speed and in a straight line unless acted on by an unbalanced force. And this can be seen in the lab and in the video I will show that the rolling string continues to roll in a straight line because there are no other forces acting on it. And we will use the concept of constant velocity in this lab because we assume that there are zero net forces and that the sum of all forces cancel out. And there are two main formulas used in this lab, which are the velocity update and position update formula. The velocity update formula comes from using F net over m is equal to the acceleration. So acceleration can be replaced in the F net over m. And for the position update formula, we know that the velocity can be calculated using the change in displacement over change in time. So rearranging that equation gives us the position update formula. For the overall experiment, we will observe the motion of some object that is moving at the same speed without changing direction. And based on this, the position of the object should change at a constant rate. So the position graph should show an upward or downward sloping straight line. And for this lab, we will also assume that the object is not accelerating. And when rolling the object, we will try not to add any extra unnecessary force or push. And we will ignore air resistance, friction, and we will only look at the x-axis movement of the rolling object in order for there to be zero net force and assume constant velocity. Here is the video of the rolling object. And using tracker, you can see how each frame goes. And based on this, you can see the graph of the position versus time, and you can see an upward sloping linear straight line. Now using GlowScript for the predicted position as opposed to the previous observed position, I use the position update formula, which is calculated by taking the average velocity, which is equal to the change in displacement over change in time. And I found 2 points using the observed position from tracker, and I calculated the velocity to plug in for the initial condition, as you can see in this picture over here. I then updated the object's velocity and position using the velocity update formula and the position update formula in the GlowScript in order to produce this predicted position curve. And as you can see, it's more curved instead of a constant increasing slope. Instead of a constant slope, it's more of an increasing slope. Now, this is the graph of the predicted and observed position on the same graph. And as you can see, as I mentioned previously, the predicted position using GlowScript is more of an increasing slope, whereas the observed position is more of a constant linear slope. And there may have been possible sources of error in this lab, such as when I was manually tracking the rolling object with the center of mass, I might not have tracked it in the same position each time, and this may have resulted in a less linear curve. And also when rolling the object, I tried not to accelerate it, but obviously this was not confirmed that I would not accelerate it. I tried my best to, and if I did accelerate it, this would result in not a constant velocity motion. And also there may have been sources of error that were given in the lab, such as friction on the floor. And for the what ifs and what does it mean, if I were to flip the axis from positive to negative, the graph would slope downwards, a negative slope, but the results would not change. The magnitude would still be the same of the position and velocity. And how many pushes and pulls or how many forces are added together to give a zero net force, we cannot determine this because of human error. And there's going to be imperfect constant velocity because of friction. And also, even though the normal force and force of gravity cancel each other out, there will be friction. So it is not possible to determine how many pushes or pulls.